In 2014, the site of what would become the largest single airport terminal on Earth was still a wheat field, and somewhere underneath that wheat field, completely unrelated to the airport that hadn't been designed yet, engineers were already planning to run a high-speed train directly beneath the runways. 5 years later, both were finished, both were working, and almost nobody outside China noticed that one of the most complicated engineering puzzles of the decade had just quietly solved itself. This is the story of how a nation built an $11 billion airport shaped like a golden starfish over a bullet train on a deadline that could not move by a single day. And by the time this story ends, you will understand exactly why engineers had to invent 65 entirely new construction methods just to make it possible. It starts with a number nobody likes to build around, a deadline tied to a national anniversary, fixed, immovable, 4 years and 9 months from the day the ground was broken, with zero room for extension no matter what went wrong along the way. Before a single truck arrived on site, 20,000 people living on that land had to be relocated. An entire community moved to make way for a terminal that, at the time, existed only as lines on a drawing, and the ground itself, once it was finally empty, turned out to be hiding a problem that could have doomed the entire structure before it ever left the drawing board. This soil was not stable. It settled unevenly across the site, which meant that if engineers weren't careful, one corner of this enormous terminal could sink faster than the rest of it. And in a structure this size, an uneven sinking foundation doesn't just tilt a building, it cracks everything sitting above it, on floor by floor, all the way up. So dozens of piling rigs worked simultaneously across the site, driving deep foundation elements into the ground, while engineers ran an unprecedented volume of testing just to verify that every single section of this future terminal would settle at the exact same rate as every other section, because uneven settlement here wasn't a minor defect. It was a structural death sentence in slow motion. Then came a decision that shaped every single challenge still to come. Instead of building several smaller terminal buildings the way most massive airports do, China chose to build one single, unified terminal, larger than anything ever attempted before, which meant every problem from here forward had to be solved at a scale nobody had engineered around before. 2 entire levels had to go underground first, before anything visible above ground could even begin, and the moment excavation opened up, that deep groundwater started fighting back immediately, pushing up from below with a force that never let up. Hundreds of dewatering wells ran nonstop just to hold the water table down long enough for crews to pour the enormous underground base slab. This whole terminal would eventually stand on. But that slab brought its own hidden danger, one that had nothing to do with load or weight at all. A concrete slab this massive can crack itself apart purely from internal shrinkage as it cures, with zero external pressure pushing on it whatsoever. So engineers made an unusual decision. Across the entire underground floor, they left deliberate gaps in the concrete, unfilled for months at a time, on purpose, because filling those gaps too early, before the surrounding concrete finished shrinking, guarantees the slab cracks along invisible fault lines the moment it does settle. On top of that, engineers formulated a special concrete mix designed specifically to resist its own shrinkage from within, layering 3 completely separate defenses against a single problem. Because at this scale, nobody was willing to trust just one solution. In one particularly clever borrowed idea, engineers even adapted a technique originally developed for earthquake-resistant buildings and repurposed it here to solve what was, at its core, a pure concrete cracking problem. And all of this was happening directly above an active bullet train construction project, running underneath the terminal footprint. Engineers building an airport and a railway simultaneously. In the same physical footprint, neither one able to simply wait for the other to finish. 2.5 million square meters of underground piping were laid beneath the terminal to let the building heat itself using the Earth's own stored temperature, while nearly 3 million cubic meters of artificial wetlands were engineered around the site specifically to absorb floodwater before a single aircraft ever landed. Above all of that groundwork, the roof itself, the part everyone would eventually recognize from the air, rested on just 8 columns, and not one of them stood straight. Every single column curved because straight columns simply could not carry this particular load geometry, and every formwork panel used to shape those curves had to be individually unique, meaning that placing even one reinforcement bar incorrectly inside that curve locked a permanent structural flaw into the concrete forever, with no way to fix it after the pour. Engineers ran over 400 separate load scenarios against the roof design before a single beam went up. Wind, snow, seismic movement. Thermal expansion, every combination tested in advance, and the final structure used 38 different beam sizes spread across 170,000 individual steel members, almost none of them identical to one another. Reducing the total steel weight made the engineering lighter, But it made fabrication brutally harder because every single one of those 170,000 pieces had to arrive on site and match its exact designated position perfectly, in the exact order they'd be installed. Get the delivery sequence wrong and the entire assembly process stops dead, because installing later sections before earlier ones causes the whole structure to deform under its own weight before it's even complete. The very first roof section was lifted into place as a single piece, with 25 more coordinated lifting operations still to come, and every single crane position for all 26 lifts had to be calculated individually in advance, because a crane positioned even slightly wrong could twist the section it was lifting out of tolerance before it ever touched its final resting point. 13 separate sections were assembled piece by piece at full height above the ground, every connection checked before the next piece went in, with steel movement monitored around the clock throughout the entire assembly process, because one unexpected shift anywhere in that structure meant pausing everything immediately until engineers understood exactly why it moved. There were 31 distinct moments where two separate sections of roof finally came together and connected, and each one of those connections was timed against live deformation data being measured in real time, because temporary supports holding those sections up had to be removed slowly, carefully, monitored constantly for any sign of unexpected movement. To understand exactly how this structure would behave under real stress, engineers built a scaled physical replica of the roof and deliberately shook it, watching precisely how it failed. Because there's a critical difference between a structure that deforms gradually, giving workers seconds of warning, and one that collapses suddenly with none at all. And this test existed specifically to confirm which one this design actually was before it was ever trusted at full scale. Only after one final structural connection did dozens of isolated steel pieces finally become a single unified roof. And 2.5 years into construction, for the first time, the unmistakable starfish shape appeared above the site, spanning up to 180 meters between supports in a single stretch, a deflection calculation so precise that even tiny errors would have compounded visibly across that entire span. Then came the glass, and almost none of the roof panels shared the same shape, because nobody had anticipated exactly how much this specific curved structure would move between winter and summer. As much as 60 degrees of thermal shift across the seasons, meaning every skylight had to be engineered not just to let light through, but to guide passengers intuitively through the terminal without needing a single directional sign, using daylight itself as wayfinding. From the central hub, 5 separate terminal arms extended outward, each one repeating the exact same structural puzzle the center had just solved, all over again, independently, while 79 gate positions across those 5 arms were being fitted out simultaneously, an undertaking so complex it required its own dedicated project management structure just to keep track of it. For the first time anywhere, departures were stacked directly above arrivals in a single vertical arrangement, and kilometers of baggage. Conveyor belts had to be threaded precisely through corridors whose exact dimensions had been locked in months before construction on those corridors even began. Fire code demanded a maximum 75-meter escape distance from any point in the terminal. But the sheer scale of this building meant some areas sat 200 meters from the nearest exit. So engineers built 29 separate emergency staircases just to bring every single point in that vast open space back within safe evacuation range, because smoke behaves unpredictably. In a space this open, and the wrong airflow pattern can make an evacuation more dangerous rather than safer. At the height of construction, 4 entire levels of interior fit-out were happening simultaneously, and the daily logistics of coordinating that many trades in that much vertical space became nearly as complicated as the structural engineering itself. In one particularly striking detail, real traditional Chinese gardens were built inside the fully sealed terminal, complete, with living plants under roof-spanning football fields, while even the solar panel brackets scattered across the roof had to be custom engineered individually, because nothing about this roof's geometry allowed for a standard, off-the-shelf solution anywhere. Over 2,000 automated lighting drivers responded to natural daylight levels in real time, all coordinated through a single central control system, while robotics, facial recognition checkpoints, and fully automated baggage handling only worked once every one of those separate systems learned to communicate with every other one. 293 separate passenger mobility systems were installed throughout the terminal. One single moving walkway alone stretched more than 90 meters, and each and every one of those nearly 300 systems required individual calibration testing before it could be trusted with a single passenger. 98% of everything used in this building was manufactured domestically, meaning entire supply chains across the country had to synchronize precisely with this exact construction timeline, with zero slack for delay. And running in parallel to all of this, an entirely separate engineering discipline was unfolding just outside the terminal. 4 runways, built simultaneously, laid out for the very first time in China's history around actual flight paths, rather than simply around the available land. Because a runway, contrary to how it looks from a plane window, is never just concrete poured flat on the ground. Standing water on that surface can cause an aircraft to hydroplane on landing, and with up to 300 takeoffs and landings scheduled every single hour, engineers had to build the largest automated air traffic control system ever constructed just to safely manage that volume, while embedding runway lighting designed to survive an aircraft's full weight rolling directly over it day after day without ever losing its precise beam angle. Beneath the runway itself, engineers built an entire tunnel specifically so that no ground service vehicle would ever need to cross an active aircraft path from above. And because northern China regularly experiences heavy haze, low visibility landing technology was treated as essential from day one, not an optional upgrade added later. On the 4th anniversary of groundbreaking to the day, the runway system was finally fully complete. And on May 13, 2019, a real Airbus A380 lifted off pavement that had, until that exact moment, existed only as calculations on paper. 19 minutes and 41 kilometers later, the bullet train running beneath the airport finally proved in practice that two entirely separate megaprojects, sharing one physical footprint, could actually function together as intended. Across 5 years of construction, up to 50,000 workers were on site at once, and the project recorded 0 major safety accidents across the entire build, a result that, under this level of deadline pressure, does not happen by luck. It happens through relentless enforcement, shift after shift for years. Engineers ultimately invented 65 new construction methods over the course of this project alone, because the existing playbook for airport construction simply did not cover a build at this scale, this speed, and this level of overlapping complexity. Test passengers moved through mock checkpoints in small groups first, but processing 10 people smoothly is an entirely different problem than processing hundreds per minute, and every single system had to be proven at that real world volume before opening day. And even with the terminal itself finished, without cargo facilities and maintenance hangars fully operational, airlines still couldn't have flown a single scheduled route out of this airport. On September 25th, 2019, the very first commercial departure lifted off from farmland that 5 years earlier had held nothing but wheat. And on that same day, one of China's oldest airports closed its doors for good. On one era of aviation quietly ending as another began overhead. From above, the finished terminal looks like a golden starfish or an alien spacecraft depending on who you ask, and both descriptions somehow fit. A structure that was, until very recently, nothing more than scaffolding, stress calculations, and thousands of engineers arguing over how to stop concrete from cracking itself apart. Now simply standing there, quietly beautiful, as if it had always belonged on that horizon.